so let's go over the bell work. So this is a review from what you learned on Monday when I wasn't here. Is graphing lines in slope-intercept form. So once it's a slope-intercept form, what is the first step to graphing? What's the first thing you need to do? Maybe you can write these steps down. Ethan? Yes, plot B. So write these directions down too. So for this one, our y-intercept is -5, so I'm going to put a point at -5. What's the second step? How do we get more points? Max?
Solve for y? Or
Well, we already
put
solved.
something in for x?
That's like pre-algebra way of doing it. But now that we have the slope, how can we use the slope to get more points? Yes. Rise over run. Right. So use M to get or plot more points. And we want to plot as many points that can fit on the graph so we can make the most accurate line possible. Yes, I know what video you're talking about. So you go up to over 3, up to over 3, up to over 3. And then you can also go down to left 3 to get points on the left side of the y-axis. Down to left 3. Because if you think about it, down and left, that's a double negative, which makes a positive. And then you're going to carefully line up your ruler or straight edge between all your points and put arrows at the ends. So hopefully that's what your first one looks like. And then the next one has a y-intercept of 4 and a slope of -4. So we'll plot 4. And if it doesn't have rise over run, like if it's not a fraction, how do you figure out what the run is?
1.
It's always 1, right? So just put it over 1. So go down 4 over 1, down 4 over 1, and then you're also going to go up 4, left 1, and then draw your line. The slope is negative, so the graph should be sloping down from left to right, which it is. And that's just a way you can kind of check that your answer matches what your graph is, or what the original equation is. Okay? So that's a review from Monday. Next, today we're going to learn about direct variation. Don't worry about writing this down, but direct variation is just, it's basically slope-intercept form. So it's like y equals mx plus b without the b. So for us, b is always going to be equal to 0. So you'll say like y varies directly with x. So there's always a number that you can multiply x by to get y. There's no adding or subtracting involved. And it's always linear, which doesn't mean a whole lot to you right now, but in the future it will when we do exponentials and quadratics. So here it says 2 variables x and y show direct variation provided y equals ax. Sorry, I was supposed to say variation. Did everybody get the notes? Just making sure. Okay. So A is the what we call constant of variation. And y is said to vary directly with x based off of whatever a is. So we can also think of your constant of variation as the slope. So when we look at it in context of a graph, we're really just looking at what the slope is. But you know, since there's no plus a number, it's just plus 0. Well, actually, we'll get to that later. So here's an example of y equals 2x. Or even somebody tried to say this as a non-example in the last class, 2y equals x. So the reason why 2y equals x is an example of direct variation is because if you can solve for y by dividing both sides by 2, and then you would get y equals 1/2 x, which is direct variation. So as long as you can solve for y and it's just y equals ax, then it's direct variation. But if you have another number that you're adding, it's like a constant that you're adding or subtracting at the end, then it's not direct variation. So can you give me an example of something that's not direct variation? Max?
Negative y equals 2x.
Well, can't we just divide both sides by negative and get y equals negative 2x? So that would be an example. So what would be something that's not an example? Remember what the key is here, Cole.
Y equals 5x equals 2.
Yes. So you can't. The idea is you can't add or subtract something. It has to just be y equals a number times x. The y-intercept has to be 0. So anything when the y-intercept is not 0, that's not direct variation. So let's do some examples. Tell whether the equation represents direct variation. So our goal, what we're going to do is we're going to get it into y equals ax form. If it can't be put into that form, then it's not direct variation. So for a, we can subtract the 2x over. And then we'll bring down the negative 3y. Divide both sides by negative 3. And you get y equals 2/3 x. So is this direct variation or not? Yes, direct variation. And what's the constant of variation? A. Constant of variation. Gabby? Where do you see negative 2 from? From the, look at your final equation. 2/3, yeah. So that means each input, we're multiplying it by 2/3 to get the output. So it'll get a smaller number. For b, we can add the x over to get y by itself. So y equals x plus 4. You don't need to divide anything because it's just y. How about this one? Reese? What'd you say? You said it is or not? You said it is? You're saying it is. Remember how we just have to have y equals ax? So you shouldn't have a y-intercept. But do you see how you have a y-intercept plus 4? So if you're adding something, that means it's not. This would be no, not direct variation. If it was just y equals x, that would be direct variation. If it was y equals 4x, that would be direct variation. But whenever you start adding things or subtracting things, then it's not. Try C and D. I'll give you a minute. Even if you can tell what it is, like yes or no, without solving for y, you want to do that anyways because you want to identify the constant of variation, which is the slope. So for C, it's really just like A, just different numbers. So when you rearrange it, you end up getting y equals 4/5 x. So this is direct variation, and constant of variation is, Gabby?
4/5.
Yes. For D, we're going to subtract the 2x over, get negative y equals negative 2x plus 3. Divide everything by negative 1 and get y equals 2x minus 3. Is this direct variation or not?
Nope,
Why?
because there's addition.
Right. So not direct variation. Well, yeah, adding a negative. Okay, let's look at the next type of problem where you're graphing. So if I'm graphing direct variation equation, remember how we said that the first step is to plot B. So what happens if we have no B? Jacob?
You go to 0 or the origin.
Right, so here it's technically plus 0, which means that it's going to go through 0, 0. Which brings us to the idea that direct variation equations always go through the origin. I want you to make a note of that. Always goes through origin. Which means anytime you have a graph of a line that does not go through the origin, then it's simply not direct variation. If you have a graph that does go through the origin, it is direct variation. So here we have y equals 2/3 x. We'll put a point at 0, and then we're going to go up 2 over 3. I'm actually going to try to, no, it won't let me make these bigger. Oh well. So 0, 0, and then up 2 over 3, up 2 over 3, up 2 over 3. We can always also go down 2, left 3, down 2, left 3, down 2, left 3. Make sure you put arrows on both ends. So it goes to the origin. And then B, same thing. So we're going to put a point at the origin. And now our slope is negative 3. So we're going to go down 3 over 1, down 3 over 1, till we get to the bottom. And then up 3 over 1, up 3 over 1, until you get to the top. Okay, once you're good, you can flip your page. So for this next part, it says write and use direct variation equations. The graph of a direct variation equation is shown. Write the direct variation equation. Remember, it's in the form y equals ax, where a is like your m, like your slope. So all we need to do is, from the graph, determine what the slope is. I would just do rise over run. Since you know that it's going to be passing through 0, 0, you could just go down and over, like pick any 2 points and go down and over, and then always simplify. So here, what is your a? What's the slope? Michael? Yes, it's going down 2 over 1. So the equation is y equals negative 2x. It's for part A. And then B says find the value of y when x is 30. So you can simply plug in 30 for x. Y equals negative 2 times 30, which is, Gabby?
60.
Yes. Also, your constant of variation is like a pattern. So the pattern is you're multiplying all of your inputs by negative 2. So if your input is 30, your output is negative 60. The next one says the graph of a direct variation equation passes through 4, 6. Doesn't give you the graph, so what we can do if you want is make your own. It's going to be passing through 0, 0, and then 4, 6. So then you need to determine the slope and write the equation. So what's our constant of variation? I think rise over run. Gabby. 6/4, which we will reduce to 3/2. Yes, because you're going up 6 over 4. Oops, this is 4, 6. So if you notice, you might notice this too in your homework, it's really just the y divided by the x. Because when you do slope, you do y minus y, x minus x, but your second coordinate is just 0. So it ends up being just 6 divided by 4, and then always reduce. So then what would be your equation? Eli?
Y equals 3 seconds x.
And then for the second part, find the value of y when x is 24. Just plug in 24. So what's 3/2 of 24? Oh, you can do this without a calculator. Ethan? 36. Just add half of 24 back to 24. 12 plus 24. All right, let's do some word problems. It says the number of tablespoons of sea salt needed in a saltwater fish tank varies directly with the number W of gallons of water in the fish tank. A pet shop owner recommends adding 100 tablespoons of sea salt to a 20-gallon tank. Write a direct variation equation that relates W and S. So we'll do W varies directly with S, which means W will be our Y. Oh, wait a minute. W is the gallons. W is our Y and S is the X, or I think it really doesn't matter, but I'm just going to do it the way the book goes. It's W is X and S is Y. But really, I'll show you that it doesn't matter. So here, if we have 20 gallons and 100 tablespoons, that's how we would convert that into a coordinate. And to write a direct variation equation, we need to know what the A is or what the slope is. So let's think. The A is basically just the number that you're multiplying 20 by to get 100. So what is the A in this case? Michael? Think. 5. Yeah, 5. 20 times 5 is 100. So y equals 5x would be the equation. And then it says how many tablespoons of salt should be added to a 30-gallon saltwater fish tank. So then you would plug in 30 for x because x is the number of gallons. So y equals 5 times 30. 5 times 30. 150. And label your answer. This would be tablespoons. TB for tablespoons. Now I'll show you in the other class, we actually did this a different way. We chose to do 100, 20. So then if you would do it that way, then A ends up being 1/5. So y equals 1/5 times x. But it's still like here, the 100 is the tablespoons, so that's your S. Sorry, so this X would be your S, and this would be your W. But over here, we're doing it this way, then the x is the w and the y is the s. So it's s equals 5w. But really these are the same thing because you can multiply a 5 over and get 5w equals s. So that's the same thing as that. So it actually doesn't matter which way you put it in the order. It'll, for a word problem at least, it'll end up being the same. Okay, and then let's do the next one. An object that weighs 100 pounds on Earth would weigh just 6 pounds on Pluto. Assume that that weight P on Pluto varies directly with weight E on Earth, which means that you can write it as a direct variation equation. So here we're gonna do P for X and E for Y. So that means our coordinate would be P would be 6 and 100 would be the E. So step 1, find out what the A is and then put it into an equation. So what do you have to multiply 6 by to get 100? Max? Let's put it as a fraction. So you know how the one that was 6, that was 4, 6, and you just divided them? So you can just divide these. So I'm going to just put A down here. So 100 over 6, and that simplifies to 50 thirds, right? So that's where your answer came from. But yes, you would just divide, but write it as a fraction. Therefore, our equation would be E equals 50 thirds times P. In the other class, we wrote P equals 3/5 times 50th times E. Is that the same thing? How is it the same thing? Can you explain? You just guess. How is that the same? Ethan?
Because, like, if P is the weight for Pluto, that means it's 350 is the weight of the Earth. So, like, the variable is the square.
Yes. Yeah. And then I was kind of getting at, like, to solve for P, you'd multiply by the reciprocal, 3/50ths. And then that's how you end up getting 3/50ths E. So, but yeah, if you are switching the variables, you just switch the, take the reciprocal of A. Okay, and then for part B, it says, what would a boulder weighing 750 pounds on Earth be on Pluto? So we're going to plug in, if we're taking our equation, we're going to plug in 750 for E. So if we're going to do it that way, then we would have to solve for P by taking the reciprocal. So times 3 over 50. You can use a calculator, but I bet you would be okay to do it without one. What'd you get?
45 pounds.
Yes. All right. Next, you are going to do an exit ticket that's in Polaris. I think it's open right now. And then when you're done with that, you will do your homework, which is 3.6 Edulastic. So you do have homework this weekend.